Hello, friends. A lot of you guys emailed me asking about question 2 in the review packet, and a lot of you guys on my last video commented on doing a problem similar to this one. So I'll be going for secant to the 4th x minus 1 over tan squared x equals 2 plus tan squared x. So we're going to start off by looking at the directions. It asks us to verify the identities, yes. But then it also asks to justify each step. So that's exactly what we'll be doing. And since it's asked us to verify, keyword verify, we will not just be simplifying it like we did in my last video, but we will be making sure it equals this exact value or this exact value. So the first step is identify which side we will be beginning with. What I like to tell my students is to always start with the harder side because it's easier to prove the easier side. So we'll be starting with, in that case, we'll be starting with secant to the 4th x minus 1 over tan squared x. So we'll begin by drawing out a table. I always tell my students it's the best way to keep your word organized, draw a table. So step 1. Let's look at the top part of our equation. It says secant to the 4th x minus 1. This is technically the same thing as x to the 4th, right, minus 1. And if we go back to what we learned in pre-algebra, we know that this is just the difference of two squares. So we can start by factoring out this to secant squared x plus 1 multiplied by secant squared x minus 1. If you guys have any questions on how I got this, I'll make a separate video explaining this further. But for now, we're going to move on, and the justification for this is just factoring. Factoring, right? All right. Step 2. Let's take a look at our Pythagorean identities. So I recommend you have these memorized for the quiz, depending on what your teacher allows you to have a sheet next to you. But if they don't, I do recommend you having these memorized. I'm just going to lay them out for you right here. That's what I drew in my last video. But we know that secant squared x minus 1, if we look at our thing, we can move the 1 over. So that will be equal to tan squared x. So, since this secant squared x is equal to tan squared x, so we can do secant squared x plus 1 equals to tan squared x all over tan squared x. Okay. And then the justification for that is the Pythagorean identity. And then we notice that the top and the bottom are both being multiplied by tan squared x, so we can just cancel those out, leaving us with secant squared x plus 1. Draw the little meter. Squared x plus 1. And the justification is cancel it, since all we did was cancel this out. All right. Now we're left with secant squared x, and this is where a lot of students get stuck. They're like, how am I supposed to get a 2 plus tan squared x from here? But what we have to do is essentially break up the secant squared x. And going back to the property, let's look at that. Secant squared x is equivalent to tan squared x plus 1. So that's exactly what we're going to do. And yes, this is allowed. You can just make this to equal to tan squared x plus 1, breaking down the plus 1, plus 1. And then you could just write Pythagorean. Finally, you can just rearrange what we already have. The answer asks for us to have the 2 in front and then add the tan. So we'll just move the 2 over here. So 2 plus tan squared x. In the justification of adding and rearranging. And that is how you achieve your answer. If you guys have any questions, feel free to email me, or you can put them in the comments down below.